Okay, perfect. Thank you so much for that introduction. As mentioned, my name is Julio Ceja. I'm a mechanical engineer at undergraduate student. I work under Dr. Jun Xing in his, it's RAMS for short, but it's Robotics and Medical Systems Laboratory. And then our project was working with the robotic optical fiber probe for thermal therapy. Next slide. Okay, some of the background for this research, we pretty much aim to work on brain tumors. A lot of brain tumors are found, approximately 22,000 actually cases of brain tumors are found and diagnosed in the US yearly. And a lot of these treatments for the brain tumors technically are not as efficient. They just elongate the lifespan of the patients by a couple months. And a lot of these are mainly therapy through radiation or prescribed drugs. And they're just not as efficient as we would want them to be. There's this, it's called lasers interstitial thermal therapy, so LIT for short. This is a new research that has, or technology that has already been proven to be efficient, which is just a needle that goes inside of the brain and it starts treating the tumors by thermal therapy. So what I mean by that is it comes in with the laser, starts hitting certain areas in that tumor, which starts killing a lot of those dangerous cells. Now, this is where our research comes into place. A lot of these LIT therapy technologies actually is just a straight probe. So the straight probe can only target certain areas. And then if we want to avoid really critical areas in the brain, then it's really hard to manipulate this. So our research lab started working on a robotic probe, which allows, the one I was working with is a 45-degree angle bend. And then this allows the robotic or the probe to bend and actually not hit critical areas inside of the brain, and makes the whole process a little bit more efficient. So here on the right picture, I don't know if you can see my cursor, this is actually one of the probes that I cut, which I'll talk more about the whole manufacturing process. And then, so it's a whole process. It's just not only creating the fiber or the piece of equipment, is also creating a tip that would aid for the thermal therapy, which again, I'll talk more about. So we break it down into two phases. The first phase is the super elastic nitinol. It's just a type of material that we cut with this PCB desktop mill. And I have a little video here on how that looks. Cut that down. And yes, so it's a long process. We have to create a mold, 3D printed, then place the probe or the piece of metal there, and then start cutting it by doing some G codes and some other things on software. This is the result. It comes with some notches, and then the notches, once we tie a tendon wire, that allows us to bend. It's almost like if you attach a string to your finger and then you pull it, it allows you to bend it, like so. And then the second phase is actually creating the tip of this probe, which is made of polydimethylsiloxane, or PDMS for short, and carbon nanoparticles. So this whole process was done by another undergraduate researcher. His name is Joel Tan, and he was kind of like my partner in this whole research project. But basically, this is a video of how it bends once you pull it. And then this motion would be done by a stepper motor, which that's another step a little bit outside of my research. Yes, as you can see. Okay, and this is the process of how to make the creation of the PDMS. So we make some silicon-based materials with chloroform and also the nanoparticles. And then, as you can see here in the video, we just mix it all in a hot plate with a stirrer. And then this whole mixture creates a lot of gases. So we have to put it inside of a vacuum and degas the whole system. And then, as you can see here, once we have that solution, then we introduce it into another mold that is specifically created to hold the whole system of the probe, and also the needle would come in here on the right side and insert the whole mixture. Once all that is solidified, then we would use the laser setup, as you can see here on the left. And then this whole laser setup would start warming up that tip by bouncing those laser particles into the carbon nanoparticles, and it creates almost like a heating zone. And then this was the whole setup that we were planning to do. And and eventually in the future we would like to get more results. So some of the expected outcomes, this was actually some of the pictures I was able to get earlier this week. They're not as efficient as we would want them to be. That's why the research is still continuing. But with the thermal camera, we noticed some heat on the tip of the probe. It's not as much as we would want, because this type of heat, it would not really do much to the cancerous cells. But of course, this is something that we would like to continue, and then also try it on more phantom tissue such as gelatin, and then eventually move on to animal tissue. So yes, definitely in conclusion, as like I said, there's more research to be done. We can definitely get larger diameter probes, smaller diameter probes for any other application. There's a lot of graduate students, or some graduate students, working with mouse brains. So that the probes definitely have to be much smaller. Higher bending capabilities, we would want the probes to bend up to 90 degrees. I think that would be great, and our professor is actually aiming to that. And of course, lastly, test all of these probes in animal tissue and see how the heat would affect actual tissue. So eventually we can do on humans. And then lastly, I would like to say some acknowledgements. Of course, first, my PI, Dr. Jun Cheng, he's been the one kind of guiding me through this whole process, even through graduate applications. Some graduate researchers, Boshan, Saeed, they've been helping us, me and Joel, through this whole research project. And then, of course, I want to give a huge shout out to Joel, because that whole PDMS system was actually created by him. I helped him a little bit, but he was the one that was putting most of the work with that. And of course, some shout out to our sponsors and our funding, the UCR Undergraduate Mini Grant Program, which they actually partially fund us with that probe. I mean, not the probe, the laser that we purchased, and also the camera. So that was great. And so thank you very much, everyone. And I can open the floor for some questions.
Okay. Thank you, Julio. You can shut off the recording.